Okay, so in this video, what I'm going to be looking at is we're going to look at 2.3 number 8, and we're going to be finding the volume using shells. And we'll use this as an opportunity to kind of talk a little bit about how it is that you go about finding the volume using shells. So when you find the volume using shells, what you're basically going to be doing is you're going to be constructing cylinders, okay? And so consequently, if you look at a cylinder looks like this. And so the volume for a cylinder, okay, is going to end up being, well, excuse me, not the volume, but we're going to be looking at the surface area of the shell, right? And then basically what ends up happening is we end up like stacking the surface areas of these shells over and over and over again. And what that gives us is it gives us the volume, right? So we kind of build this out using these cylindrical shells. So when we say that, the surface area for a shell is going to be 2 pi r times h. Okay, so that's the circumference times the height. So 2 pi r times h. So our trick here when we're actually building the shells is, what is the radius and what is the height? Once we find those two, then it's just a matter of integration. We go in, we integrate around, we go out, we integrate around along one of the axes, either the x-axis or the y-axis, along our bounds, and what we end up with is we end up with the entire volume, right? That's what it does when we integrate. We stack things up. We stack them and we kind of like let them accumulate, all right, so that we have lots and lots and lots and lots of these shells. So what we need to do first is we need to figure out what R is, what H is, so that we can actually figure out what one of these shells is. Okay, so we just want to figure out what one of these shells is. Now, in this problem, we're going to be finding the volume using shells. We're going to go from y greater than or equal to 2 to less than or equal to 11 for f of x, or excuse me, g of y, rather, equals 5 over y, and y equals 0. So these are going to be our bounds, and these are our bounds, and these are the functions that we're going to be taking our values with respect to. And we're going to be rotate around the x-axis. Now, when I rotate around the x-axis, what that means is if I look at this picture that I have here, okay, and let's make this just a little bit larger so that we can see it a little bit better. So we'll zoom in just a little bit, okay? When I go in here, what I want to notice is here's my curve, okay, that's the top end of my curve. Here's the bottom end of my curve, y equals 0, and then here's the region that we're going to be rotating. We're going to be rotating around this region, okay? Now, the radius, if we imagine the cylinder is going to look like this. Okay, so there's the cylinder right there. Okay, and so if we look here, here's the radius for the cylinder, and then this thing here, that's going to end up being the height. Okay, so the radius is going to be the distance, well, is essentially going to be a value on the y-axis in this case, one of these values going from 2 all the way up to 11. Okay, and my height is going to have to do with the functions here. Notice that those functions, as I move up in the y, right, as I move up along the y values, okay, what happens here is the radius, right, increases. So for example, I look here, here's a new cylinder, okay, there's another one, and here's its height, and its radius now has gotten longer. Its radius is going to be that length of y, okay, and its height is basically going to be the top curve minus the bottom curve right there, okay? So when we're thinking about rotating about the x-axis, we're going to be having to be thinking about it in terms of y. My radius is going to be the value for the y values, all right? Starting with 0, or actually starting with 2, and then moving upward. And so as I change dy, right, okay, I'm going to be changing my y value. So that's my radius. And my height is going to be the difference in these functions. So let's kind of just take a look at this. Right, there's my height. If I think about the bottom, here's another height, right, as I change along y, and here's one radius, and here's a different affiliated radius. Okay, this distance right here, that's y. Okay, that's like it starts at y equals 2. That's just y. And this distance right here, it's going to end up being 5 over y, right? Because that's the furthest thing from the y-axis, minus 0, which is just, again, 5 over y. So now I can actually visualize what my cylinder is going to look like here. Okay, I'll take this back. Now I can visualize what my cylinder is going to look like. If I imagine here now, this radius, that radius is going to now be y, and my height for my cylinder is going to end up being 5 over y minus 0, or just 5 over y. So that's going to end up being my height. Y is my radius, 5 over y my height. So I plug that in now. I'm going to take an integral from 2 to 11, and that'll be now 2 pi r, 2 pi times y, times 5 over y, dy. And that is the volume of the cylinders. And that is the volume of the cylinder using shells. Now we just go in, we simplify. We end up with 2 to 11 of 2 pi times 5 dy. So that equals 10 pi times the integral from 2 to 11 dy, which is going to end up equaling 10 pi, 10 pi times y integrated from 2 to 11. And that'll be then 10 pi times 9, which is 90 pi. And that is your volume. So just to review here, when we're thinking about things in terms of shells, okay, what we have to think about is in terms of radii and also in terms of height. Depending upon which axis you're rotating around, that your height changes and your radius changes, okay? But basically, the radius, if we want to summarize, the radius is the distance from our starting point, or from our x or y value, right, depending upon which one you're rotating around, to the axis of rotation. So, for example, if we had instead been rotating here around y equals -2, there'd actually be a longer radius, right? It would actually be my y value plus 2. We'd have to actually add 2 in order to get to the axis of rotation. So that's our radius. And height equals the difference in the boundary functions. The radius is going to be perpendicular to the axis. So in this case, since we're doing it via the x-axis, we're going to need the y values to be my radius, and my height, okay, is going to be x values, and so it's going to be parallel to the axis of rotation. And that's how we construct shells. So I hope this was beneficial for all of you.